Okay, so we're going to on page 63. Defining and evaluating a logarithmic function. Example 1. Complete the input and output for f of x equals log base 2 of x, and then graph f of x equals log base 2 of x. Okay, so let's go ahead and use Desmos. Let's go ahead and go to the table. And 0.25. So we need to get this out of the way. Now we're going to need to actually use functions. I believe if from my last years ago videos, feels like years ago, but we can do there. Oh, wait, let's get back into this box. So function, we want, it's under calculus, we want that one. So then the base is 2 of 0.25. Then home, there's our point. So that's -2. And so we don't have to keep going to the function. I'm just going to go back over here and do it this way. 0.5, 0.5. That point is -1. Then when x is 1, zero. When x is 2, it's 1. When x is 4, it's 2. And when x is 8, that's 3. Okay. So to graph, you have the table. Now let's go ahead and graph those points. So 0.25 is about right here, -2, which is about right here. 0.5 is about right here, -1. 1, 0. 2, 1. Oh, 2 1's right here. 4, 2 is right here. And then 8, 3 is right here. Okay, there's your function. All right, let's take a look at the next page. All right, step 1, the domain. If f of x is x greater than 0, the range of a log is always -infinity to, fix that, positive infinity. Okay, step 3, the end behavior of f of x is, as x approaches infinity, f of x approaches infinity. As x approaches 0, f of x approaches -infinity. Step 4, the graph of the only x-intercept is at 1. Step 5, the graph has no y-intercepts. The graph has a y-axis as an asymptote. The function has negative values on the interval 0 to 1, and the function has positive values on the interval 1 to infinity. The function is increasing throughout its domain. The function never decreases. All right, let's take a look at the next example. Okay, so let's go ahead and back to our Desmos table. Okay, so when x is -2, we do 2 to the -2, which is 0.25. -1, 2 to the -1 is 0.5. 0, 2 to the 0 is 1. 1, 2 to the 1 is 2. 2 to the 2 is 4. And then 3 to the 2 to the 3 is 8. Okay, so let's go ahead and graph. We got the table there. So negative 2.25, negative 1.5, 0, 1, 1, 2, 2, 4, 3, 8. Okay, there's your graph. All right, step 3. The domain of f of x is negative infinity to positive infinity. The range of f of x is y greater than 0. The exponential function is 1 to 1, so no restrictions on this domain are needed in order for its inverse to be a function. Find the inverse of a function. So we change f of x to y. That's 2 to the x. We switch x and y. X equals 2 to the y. And then we take log base 2 of x to both sides. So log base 2 of 2 to the y. And the reason we do that is because this cancels and you're left with log base 2 of x equals y. Now, the domain of the inverse is x greater than 0, and the range of the inverse is y, such that it's negative infinity to positive infinity. All right, go ahead and finish that up. Example 3. Enter the exponential equation b to the x equals y in logarithmic form. The logarithmic form of b to the x equals y is log base b of y equals x. Okay. Example 4. Enter the logarithmic equation log base b of y equals x in exponential form. The exponential form of log base b of y equals x is b to the x equals y. All right, go ahead and finish up. You know, as an example, start working on your assignment and have a wonderful Wildcat day.